lenses today.
What's the green and orange thing on your desk?
Oh, it's
That's
a
a
laser
thermometer.
thermometer. So like,
Oh yeah, I remember that.
really it's
accurate.
20 Celsius up there, and it's 21 Celsius there.
Wait, can you read people's temperature?
What's in
Sometimes I
inside my
take
mouth?
my kids' temperature when they're
You have to
asleep.
do
I'll
this.
change to Fahrenheit. So
What's yours,
Christina
Christina?
is 94 on the
Wait,
forehead.
hold
You're only 91 and a half.
You sick?
I'm
that
so
bad?
proud. I
No.
just
Well,
took a
hey,
shower.
shine on my.
Yeah, because your head's really wet. That's why. Or yours outside.
Yeah, my
Or
hair is wet.
some people just.
Shine
get
on
a
my
little
hand.
colder than
People
others.
say my hands are always cold and clammy. What's my hand?
Oh yeah, hands are definitely colder than a 72.
Hey, do mine.
Mine's 66.
Someone's mouth.
That's 71.
How hot?
78.
I've got 78. Ugh, my hands are
76.
hot.
So yeah,
That's weird.
but this is a great way to take a temperature like with a closed flask, but you can't stick a thermometer in, for example. Okay, so does everyone have a compass today?
Oh, we
Did
were
anyone
supposed
have a
to.
compass when they did their homework?
Were we supposed to?
I just guesstimated.
Oh, hey, I actually
Oh,
tried.
that
Okay.
compass.
Yeah,
Oh,
guesstimating
I
doesn't
actually
actually
Probably why my
work here.
joints were really bad.
I actually tried
Yeah, my
doing
drawings
drawings
are
on a
really
separate
bad.
piece of paper.
Yeah, I
because
used a
remember-
ruler.
I couldn't even
Me
barely
too.
do it when you showed them to me yesterday.
The drawings are a bit of a challenge.
Yeah,
I'm
I'm
gonna
so
be like
confused.
you
I
and
left all
I
the
hate
practice
this.
problems blank. Well, I did one of them, but
Miss Mathias,
was
I was
really
able to
lost.
figure out,
Like,
by
okay.
the numbers, if you look back in the chapter, you can figure out what
I don't like this.
classification or whatever they were under, like if they were
I think this is the
um,
coolest chapter ever. I
real,
don't like the
I
problems. I don't mind the like reading about it. I
virtual,
think that's
like there was three you had to determine
like
by.
at some point,
Right.
But you can determine it by the question anyway from the numbers.
Can
and
you?
I
I
didn't know
can't.
they kept going back.
Probably
and
can.
forth.
I just don't
better.
have enough.
No, there's
I
like
didn't know
samples
that.
where like
Like
in
one of
the
those and you're like,
You want to see your drawings?
in the
Sure, I'll see your drawings. Did it work for you though? Did you actually get an image that was what the book
Kind of.
said?
I mean,
Oh,
it wasn't
I use the
exact,
compass.
but I mean, it didn't
No,
give
I
an exact
took this like
answer.
a
It wasn't, it was just saying virtual
that
or
feels
like
like
that.
what?
Because see, like,
You can see by the.
Well, it should go through the
well, but if you
the
think
made
about
sense
it,
once-
okay, so like your radius
Like I
here
figured out that your
is
lines were always supposed to be
what,
above
that's
the object.
what,
Like here, I messed it up and I did it below it.
centimeters, right? But if it says your radius
And
is
so like
like
it's never
10
supposed to be above.
centimeters,
it.
then
getting
do you see how the things are gonna hit
Yeah.
slightly different place?
How do you know? How do
You do not. I don't even know what that question is, but
You did
we've all
not.
got to
I
know.
forget
That
what it
is
is
so
either.
Okay,
should eat this.
so did everybody do practice problems?
Yeah.
Did,
Not all of them. There was only
Yeah.
3.
would you
I did
guys,
three. I did.
you do on your own? Would you guys
Yes, I
like
did all the
to
on
see
your own.
practice problems or extra practice problems or ridiculously made up problems or
Let's
like
try
what
the
would be
made up.
most helpful? Ridiculously made up problems.
I like the practice problems.
You just want to do practice problems. All right, so don't look at your answers. That's the first key to redoing these practice problems because it really doesn't matter how many times you've done them. They don't keep in your head anyway. So here's how we do them on the board. Okay. Well, first off, the first bunch are mirrors, right? So what kind of mirror doesn't have any spherical aberration? What's the best kind of mirror to use so that you have a
A
perfect image?
Parabola.
Parabolic mirror. Okay.
I was so wrong. Lauren.
Why don't we just buy a bunch of those instead of using spherical mirrors?
Because they're expensive.
They're expensive, hard to make, not easy to get a hold of.
Wait,
so.
do people actually have them in their house? No.
No,
No, we have flat
the only
mirrors.
way you're going to use a parabolic mirror, yeah, flat mirrors. Like for cars, maybe spherical mirrors. You know, to like the rear view mirror might be spherical, kind of. You can see the aberration on the edges of spherical mirrors.
Oh, it must be spherical because it says objects in mirror are closer than they appear.
Well, it might just
Or
be
would
a
that be-
magnifying. Well, yeah, it would be spherical.
I know like
Ooh,
Ooh,
the
so
windshield.
mine.
I guess
Like,
that's
that's
good.
on our
I think.
SUV,
Or would that
my
be
dad like
managed?
added extra
Yes.
small mirrors in the corner and like
They actually
They're
do.
round.
I think that would
like,
be magnifying.
Well, but they can be round but still flat,
Well, like,
or they
they're
could
not
be
flat, they're,
spherical.
like
Yeah.
arced.
Objects in mirror.
So you
It's-
can
it's
see
really-
different
it's-
angles.
It's
So it looks
not
like
really
they're farther
that
away,
much,
so it's the
but
opposite of
there's still some of an
magnification.
angle.
So they'll have a
So
radius of
parabolic.
curvature
Yeah,
as
reducing
if they
it.
were a circle for
Which makes them
real.
look farther
Is that thing
away.
filming?
Yeah.
Yes.
Hi, Sam.
Hi, Sam.
So, mirrors. If they were parabolic, truly, like
Ooh,
a real parabola instead of
So they can see
spherical, you can see like, I mean, if it were spherical, it might kind of imitate this side of a parabola, right? It's pretty close, and it's cheaper to make, so it's kind of worth the problems to make the cheaper mirrors and have them more accessible. But if you want optics, like in a long-range telescope or microscope or something like that, you need good mirrors with no spherical aberration. It's worth the cost of the parabolic mirror. So, what else am I supposed to? I'll just look at lecture first instead of jumping right in. So, let's see. The law of reflection. We'll do a little lab about this later. What is the law of reflection?
The law of reflection says
Is
the angle of reflection equals the angle of incidence.
That was
Okay,
actually
great. So if I shine this laser at this mirror here, am I hitting it? I can't even tell. Where would it?
Oh,
reflected?
that is so cool.
Okay.
So
You've
it
never
makes
done
the-
that?
How did you do that?
Well, the angle of incidence equals the angle of
I've never
reflection.
been-
So the angle
like, I've
here,
seen
angle
I
there.
always learned this. Angle in
Oh,
equals
so
angle
it's
up.
So you guys are actually gonna. I told you not to shine the laser at stuff.
it's right over there on
It's
the
right
wall
over
by the
there.
door.
Don't hit Nick. Okay,
He's trying to
so
hit me.
That's so nifty.
It's right there on.
so you guys
No,
are
look
gonna
behind
do a
you, on the
lab
wall.
where
Look behind you.
I have 3 mirrors.
That's so
So we'll
cool.
do like
Oh, like, we
2,
could, like,
2, and
we could
3.
set them up so we could like.
I put a target in that room over there, so you guys have to hit it later.
Awesome. This is gonna be all.
I pick a location that I shoot the laser, and you guys have to hit the target before I turn it on. You set up your mirrors, and then we see what happens.
I probably shouldn't look at that laser. Turn it off.
I'll tell you
Like
where
the
I'm going to
line.
stand, and I'll show you where the target is, and then you have 3 mirrors that you have to get it to hit.
Has someone actually gone blind from looking at a laser?
You'd have to look for a while, so
Oh,
don't.
It's like looking
5
at
minutes.
the sun for a long time, but different.
Just like.
Okay, so virtual image. Now pay attention because we're going to go through everything this week so we can fool with labs next week because I don't have a handle on everything I want in these labs. So you guys are going to experiment for real with me next week. Yes.
Are we gonna have to write up a lab?
No.
And I'm not gonna be here next week.
Oh. Well, you can play with my lenses and mirrors someday if you want. So when you look in the mirror at home, on your flat mirror, are you seeing a real image or a virtual image?
A rail.
Virtual.
It's virtual. Okay, so here's the mirror, here's you. How's that, right? When you look at the mirror, you see the image right behind the mirror, right? But a mirror always, when a light ray hits it, the ray reflects back off of it, right? So you know that any real image would have to be on the same side of the mirror as yourself because all light rays are completely reflected, none pass through. So you have any image that's inside, looks like it's inside the mirror, the light rays are actually, what's the word I want there?
Reflective.
No.
Ooh.
Ending?
That's pumping really hard. You'll
Extrapolated.
see the thing in the bottom start smoking.
You extrapolate your lines. Okay, Sam, we're having an aside over here because we have a fire syringe and they're trying to start a
Wait, does it
fire.
actually happen?
Yeah.
You can spark it. Only Justin so far has managed to make it spark, but you have to just push like one
I'm giving
very hard
CPR to
push.
the thing.
Multiple pushes don't
Go.
seem to work. It needs to be like one really hard push to get the spark. You guys can put a new piece of cotton in at the end of class if you get everything else done and see if it works.
Oh,
What's
it's
really cool
smoking.
is when you get like a dot of something on your mirror, and you can look at it at an angle and see the back of the dot.
Kind of nice, Martin.
Did you see
Because
it?
it's like a
Yes, I
sheet
know.
of
I
glass
thought it
over like
was
silver paint or something. So
Oh.
you're seeing it through the glass reflecting off the silver paint, so you see the
see
back
what
of the
you're
dot.
Don't break it.
So
It's really
for-
cool.
If we had like a circular mirror would like a reflection, would that not be like that one?
No, it wouldn't be like that one because you, number one, have the curvature.
You ever looked at
affecting
yourself in the back of a
the
spoon?
image. Yeah.
Yeah.
Or like, do you girls have a makeup mirror? I could not find
I
one.
do.
I have one.
I have 7.
I couldn't find a magnifying makeup mirror. My kids have run up with all my mirrors. I was lucky I found 3. But if you move your makeup mirror far enough away, your image will actually invert.
See, I always just saw it get really, really big and blurry and you didn't know what was there.
Ooh, you can do
You
that with
will
a magnifying
eventually
glass.
invert.
if you hold it like so it's showing something, and then
Smells weird.
like
Mhm.
up close, and then you move it away, it starts getting bigger and really blurry, and then at a certain point it gets tiny and clear and
Yes.
and
that's the
upside
focal
down.
point.
It's upside down.
So next week, that's what we're gonna do. We're gonna set a ruler up on a stick. We're gonna measure focal points of mirrors and lenses and like try to see where does the image invert, where is the image clear, and try to calculate what the focal point and the radius of that particular lens is. But what those lenses are labeled and what I found experimentally are two different things, so I just want to see what you guys find experimentally. So, the focal point is half the radius, so if you have a mirror, so let's say you've got a spherical mirror, right? And now what I do here is if it says like the radius of curvature of the mirror is 5 centimeters, I use 5 inches on the board. It keeps things proportional, but it makes it big enough that we can actually draw it with a marker. So, well, I'll look at the problem real quick. And the first one says an object is 3.5 centimeters from a concave spherical mirror whose radius of curvature is 5 centimeters. So here, now I make sure it pivots. So when you guys have to draw these, I try to hold my pivot point still. I put it at 5 inches here, and then I just pivot like this. And I could hopefully draw a circle with a 5-inch radius, okay?
It's better than mine.
But with a compass, you guys will have better luck. And I should also figure out where that would be. I'm gonna draw my line through, hopefully, kind of the middle of it. And then it says, okay, so the radius is 5, well, inches in my case. So I can mark where the center of that circle would be, right? Okay, so it says this is a concave mirror. So which side are we gonna have our object on? Oh, thank you.
The
Left side.
Left side. Okay, so my object is 3.5 centimeters from the mirror. So I always, like the book does, draw a little arrow for the object. Okay, so here's my radius.
Listen, guys.
Yes.
Okay, so why wouldn't the object be just like a little dot versus the arrow?
Because it's hard to see if it flips. Because the dot, you wouldn't be able to tell if
Right.
it had flipped.
And
Oh, okay.
I make it of a size where I can tell if it's magnified or
Okay.
smaller, where I can tell if it's inverted or whatever.
Okay.
I mean, you could draw a stick figure or a cat or whatever. It just needs to have some height so you can tell where it is. And then where would the focus be of this mirror?
At 2.5 inches.
Right, because it's half of the radius. Pay attention. Okay, so of course I always end up ruining my drawing. So there's my focus, there's my radius. Now next week we really need to try to figure out what this really looks like for real. But it is cool because like you can see, like you can use a lens to make a virtual image on the wall, and you can, I've never gotten a real image out of a lens, particularly like one hovering in the air between me and the lens, but you can try. So when you go home, I want you guys to think about,
I think it's like changing the size or something. It's like slightly magnifying it.
I want you guys to think about where you would put a lens to try to make a real image, where you would put a lens to make a virtual image, what you would do with a mirror to find the focal point. Just think about actually using these things so that when you come in and try to use them, you'll have some ideas, because I need ideas, and well, you guys are smart, so I'm going to pick your brains. So we want to figure out this drawing. I'm going to use color because color is very useful, and I need markers for that. So where would I draw my first line in a ray tracing diagram to figure out where the image would be of this object? I want thin pens. First line would be what?
Horizontally,
So you want it to come
it goes,
past the object horizontally.
and then just go back through the focal point.
Okay, so we'll do it this way.
Josh, pay attention.
Uh-huh.